So let's look at what happens when we not only look at just the square root, but when we bring in a real and an imaginary part. So remember we said we want real plus imaginary, okay? We say that that's A plus BI. We're going to have an I because it's imaginary. So think about you've got a real and then an imaginary piece. Those two pieces are separate. Just like I can't combine an X and a 7 because X plus 7 is not 7X. They're two separate things. That's the same way a real and an imaginary number is. Okay, they have to be separate. Okay, so let's look at what I mean here. We're going to simplify. Let's say we had something like 2i plus 3 minus 7i plus 4. Okay, we're just talking basics here before we get into this whole big idea of simplifying big complex numbers. So all we would do here, we would combine these like imaginary terms. So I'd have a negative 5i. And then we would combine our like real terms. So you see, if you notice, I've put the real part and then the imaginary part. Okay. So when we are solving, or excuse me, when we are simplifying these complex numbers, we want to keep them separate. If there's an imaginary, it must be separate. Okay, so that was just baby steps. Let's look at what it's actually going to look like. Okay, so I might see a problem like this. Okay, so I have 15 plus the square root of 25 plus 5. Okay, so I need to simplify this. So the first thing that I'm going to do, I'm going to first start off with my square root. Okay, so I'm going to look at the square root of 25. Oh, I know the square root of 25, that's 5. So I'm going to have 15 plus 5 over 5. Now there's nothing imaginary about this, so I can just combine it and get all real numbers. So 15 plus 5 is 20. 20 divided by 5 is 4. I've got a real number. Okay. Let's say this time we had something like 12 plus the square root of 90 over 3. Okay, well, I'm going to do the same thing. I'm going to simplify this square root, except this time that's not a perfect square. Okay, so let's see. Let's make our little tree for 90. 90, that's 9 times 10, which is 3 times 3 and 2 times 5. So I've got 3. The 2 and the 5 have to stay under, so I've got 3 square roots of 10. Okay, so what I really have is 12 plus 3 square roots of 10 over 3. Now I don't see an imaginary, but I don't know how to do that. So the only thing at this point that I can do is I can simplify all of my numbers that are outside of the square root. Only numbers outside the square root. So 12, 3, and 3, those can all reduce. So I'd have 1, 1, and 4. So my answer would be 4 plus the square root of 10. I could put that 1 in front, but I don't have to. Okay, so I still didn't have anything imaginary yet. So let's simplify one where we end up with something imaginary. Let's say we have 3 plus the square root of negative 49 over 2. Okay, so I'm going to start off the same way. I'm going to look at that square root. Say, yeah, square root of 49, that's a perfect square, but oh, it's negative. So what I have is 3 plus 7i over 2. Ooh, now that right there, I can't actually combine those like I did the last one where I had 15 plus 5. I can't put 3 plus 7i because they are, one's real and one's imaginary. So I can either leave it like this, or another way to answer would be to split it to be real and imaginary. So basically all I'm doing is I'm taking that 2 and I'm going to split it into both of those two pieces. Okay. All right, let's try one more with this imaginary. Make sure we can simplify. So let's say we have 12 plus the square root of negative 48 over 2. Okay. So I'm going to look at this square root of negative 48. Not a perfect square, so I'm going to come over here. I'm going to make my tree for 48. So 48, I know that's going to be 24 and 2. 24 is 6 and 4. So that's 3 times 2 times 2 times 2. Okay, so let's see. I've got 2 times 2. I've got another set of 2's there. And then that 3's left over. That's going to leave me with 4 square roots of 3. Oh, but it was negative. So that's going to leave me with 4i square root of 3. Okay, so let's see what that looks like. I've got 12 plus 4i square root of 3 over 2. Okay, so at this point, I can try to reduce these. I've got a 12, I've got a 2, and I've got a 4. Remember, I can't do anything with that 3. So those can all reduce. That'll be a 1, a 2, and a 6. So I can have 6 plus 2i square roots of 3. Right. So now we see how to come up with a complex number, how to simplify just the imaginary, and then how to simplify a complex number in general.